Hi, very good morning to one and all. This is Dr. Rajshekar Medidi, Kebri University, Associate Professor in Chemistry, Somali region. Today we'll discuss about the very important topic, that is fundamentals of titrimetry. So the basic chemistry, very important point of view to discuss about the what basics are needed in the performing the chemistry laboratory. So titrimetry is consisting of mainly four types of reactions are important to see that. Number one is acid based titrations, and the second one is complex aromatic titrations, third one is redox titrations, and the fourth one is precipitation titrations. So these are the four important reactions that are most important in the titrometric analysis. So coming to acid based titrations, in which acid or basic titrant reacts with the titrant, that is a base or an acid. In acid based titrations, if you see, an acid is reacted with the base to produce all the acids react with the bases to produce salts. That is a common reaction. So in the titrometric analysis, coming to the acid based titrations, we'll be using phenolphthalein indicator or methyl orange indicator can be used. And coming to the complex aromatic titrations, here the complex formation will take place. The reaction between the titrant, the complex formation takes place by means of adding the indicator. It forms the complex that comes under the complex aromatic titrations, that is metal ligand complexation forms. And the third reaction is redox titrations, in which the titrant is an oxidizing or reducing agent. In these redox titrations, the term redox means reduction and oxidation combined takes place. So the reactants involving the reaction undergoes reduction and oxidation also. So this is comes under the redox titrations. And the next one is precipitation titrations, in which titrant and titrant form a precipitate in this reaction. So these are the four important basic titrations in the titrometric analysis. The next one is very important things we should understand here is elements of titrometry. Elements of titrometric analysis is very important. So today we'll discuss about the some elements here. Standard solution. First of all, we should know the definition of standard solution, and also we should know the primary standard solution and secondary standard solution definition, titrant definition, and definition of titration, and what is the definition of equivalence point and end point indicator, titration error. All these things are basic elements in the titrometric analysis. Now let us see the standard solution. What is meant by the standard solution? The solution of accurately known strength is called standard solution. The solution which is accurately of known strength. Generally, we will use the standard solutions to identify the strength of other solutions, maybe the secondary standard solution. So simply to understand, standard solution is nothing but the known strength, we can say. And the second was primary standard. A primary standard is a compound of sufficient purity from which a standard solution can be prepared by direct weighing of a quantity of it, followed by dilution to give a defined volume of solution. The solution produced is then called a standard solution. Simply to understand what is meant by standard solution is, it is a primary standard solution means it's a primary, it's a compound of sufficient purity from which a standard solutions can be prepared. So primary standard is a compound of sufficient purity from which we can standardize the other solutions. Okay, that is about the primary standard, which is always useful to get the strength of other solutions called as secondary standard solutions. And coming to the secondary standard, what is called as secondary standard? Secondary standard means the name itself indicates it's secondary one. So it should be titrated with the primary standard to get the strength of its own by means of by means of reacting with the standard solution. We'll get the strength of the secondary standard. So it can be defined. It is a substance which may be used for standardizations and whose content of the active substance has been found by comparison against primary standards. So that is about the secondary standard. That is the definition. And titrant. What is meant by titrant? The reagent of known concentration is called as a titrant. So whenever we use the titration process, we will take the burette. Generally, we will take the burette consisting of hydrochloric acid or any other acid substances, acid solutions, because it is difficult to pipette out the acid solutions. We can take it in the burette. So the reagent of known concentration, the burette solution always consists of the known concentration. For example, it's hydrochloric acid is an example we can say. Take it in the burette. So all the titrant, Titrant, the spelling is that reagent of known concentration is called as titrant, for us to know. And titrant, what is meant by titrant? Basic element, this is also very important. So the substance being titrated is called as titrant. The whatever substance that is there in the conical flask that is to be titrated to know the strength of it by means of the standard solution in the burette. So that is called as the titrant. We mean to understand. Titration. What is meant by the definition of titration? The process of adding the standard into the unknown solution until the reaction is just completed is termed as titration. What is that? The process of adding the standard into the unknown solution until the reaction is just completed. Titration means simply the burette solution consisting of the standard solution is titrated with the conical flask containing the unknown solution, from where when both the reacts together and finally the reaction is just completed. That is called as titration, simply to understand. And equivalence point. The point at which the reaction is just completes is called as equivalence point, or theoretical endpoint, or stoichiometric endpoint. So the point, exact point where the reaction is just completes. For example, 10 ml, we have taken 0.1 normal solution of hydrochloric acid is taken in the burette, and a 0.1 normal solution of maybe sodium hydroxide is taken inside of the conical flask. When the reaction is done between this hydrochloric acid and sodium hydroxide in presence of methyl orange or phenolphthalein indicator, so the endpoint should be exactly at 10 ml, because if 10 ml of sodium hydroxide is taken in the conical flask and the same 10 ml of same strength, it should consume, the hydrochloric acid should be consumed from the burette. So the point at which the reaction just completes, the exactly 10 ml, is called as the equivalence point. Then what about the end point? The point of reaction between the substance and the standard solution is practically complete, is called the end point. So this is also similar to equivalence point, but there is some small differences there here. The point where the indicator changes its color also, it can be called as endpoint. The indicator suddenly converts its color, it changes its color. For example, if you see hydrochloric acid and sodium hydroxide in presence of phenolphthalein indicator, we can see the color change is very sharp. So pink color appears in presence of basic medium, suddenly it changes to colorless in the acid medium. So whenever excess amount of hydrochloric acid is passing from the burette into the conical flask, that excess drop, because of acidic in nature, changes the color from pink to colorless. So the point at which the indicator changes its color is called as endpoint. Mean to understand. And final indicator. What is an indicator? We can see the indicator substance that changes color at specific pH. So indicator is a substance which is color solution, which is added between the titrant and titrant. So when the reaction completed, it will be expressed by means of change of color. So that is about the indicator. There is another definition, small definition, and the class will be ended. Titration error. The difference between the endpoint volume and the equivalence point volume is a determinate titration error. Very different. Titration error can be defined as is equals to, titration error is equal to volume of the endpoint minus volume of the equivalence point. Small error. The difference between the endpoint volume and the equivalence point volume is called as the titration error. This is about the basics of titrimetry and the basic elements in the titration process. So thank you very much for watching this video. Thank you. We'll meet again in the next video.